Dimensional analysis, Buckingham Pi theorem and its application, similarity laws, Reynolds and Frod's law, dimensional homogeneity principle, two dissimilar quantities cannot be added, subtracted, or equated. In other words, each term in the grounding equation of any natural law must have same unit. 1 kg plus 1 meter is equal to meaningless. F for Newton, MA Newton, both are Newton. Buckingham Pi theorem is based on principle of homogeneity. Buckingham Pi theorem, a functional relationship involving n physical variables, can be reduced into an equivalent relationship involving n minus m dimensionless numbers where m is total number of fundamental quantities required to describe all n variables. Fundamental quantities mass kg, length meter, time seconds, temperature Kelvin, current ampere, luminous intensity candela, amount of substance mole. Steps in dimensional analysis. List all variables along with their dimensions and unit. Select a repeating variable equal to m. The repeating variables should be selected such that they together must involve all m fundamental dimensions. The thumb rule is select first repeating variables related to geometry, second related to flow property, and third related to fluid property. Obtain n-m pi terms by combining each of the remaining variables with the suitable exponents of repeating variables. The values of exponents can be obtained by equating dimensions on both sides. Note if any variable is dimensionless, such as efficiency, angle, then variable itself is one of the pi term. If two variables have same dimension, then their ratio is one of the pi term. Any pi term can be replaced by its suitable powers or any other combination with other pi terms without losing generality. Pi 1 can be replaced by root pi 1 or pi 1 pi 2 power 2 by 3 by pi 3 square, etc. Okay, this is a question. First, all terms are there. From that, we can get m fundamental 3 mlt. N total is 6. N minus m is equal to 6 minus 3 is equal to 3 pi terms. Repeating variables g d v rho. Okay, which covers all of them. Pi 1, pi 2, pi 3. Take T D1 power A1 B1 C1, then finally equate all powers to 0. We will get the values. Finally, we will get pi 1, pi 2, pi 3. Pi 1 is function of pi 2, pi 3. From that, we can get T by rho square is equal to. Okay. Another question also based on same problem. Advantages: dimensional analysis reduces number of variables in experimental study. Therefore, time, cost, and effort required in experimental study is reduced by huge factor. Effect of any variable on dependent variable can be predicted by changing other suitable variable. Example: effect effect of viscosity on friction factor can be predicted by changing velocity instead of viscosity. F is equal to pi of Re, K by D. Mu Re by 2, F is equal to F1, V by 2, Re by 2, F is equal to F1. Performance of full scale product can be predicted by conducting experiments on geometrically similar model. Example: drag coefficient of car can be predicted by conducting experiments on small car model such that Reynolds number for both flows is same. For conducting experiments on model different fluid from actual prototype fluid can be used. Example: drag coefficient of submarine can be determined by conducting test on submarine model in wind tunnel. CD is equal to f of geometric shape, RE, FR, MO, K by L. These are not required. FCD is equal to f by f of shape, RE. Okay. In physical phenomena, if only one pi term is present, then its value must be constant. Similarity loss. The model replica. LM, BM, HM, prototype actual, LP, BP, HP. Prototype actual product for which performance need to be predicted is called prototype. Model geometrically similar replica of prototype on which tests are to be conducted is called model. Generally, model is smaller in size, but it is not necessary. If prototype itself is very small, then model can be larger than a prototype. In order to predict correct results for prototype, model must satisfy following conditions. Geometric similarity. Model and prototype must have same geometric shape, that is all linear dimensions must be proportional and all angular dimensions must be same. LR is equal to LM by LP is equal to BM by VP is equal to HM by HP. Length ratio. Area ratios. AR is equal to HM by HP into LM by LP is equal to LR square. Ratio of two similar areas. Similarly, VR is equal to LR cube. Volume ratio. Kinematic similarity. If velocities at similar points in model flow and prototype have same direction and proportional magnitude, then model flow and prototype flow are called kinematically similar. VR is equal to VAM by VAP is equal to VBM by VBP. So on. Dynamic similarity. Forces acting on fluid particles at similar location have same direction and proportional magnitude, then model and flow prototype are called called dynamically similar. When dynamic similarity is satisfied, then forces acting on various parts of model and prototype are proportional. In order to satisfy dynamic similarity related to a particular force, the dimensionless number related to that force must be same for model and prototype. Example: for dynamic similarity of viscous force, Reynolds number must be same for model and prototype. Sigma F bar is equal to MA bar FV bar plus FV bar is FV bar plus minus of MA bar is equal to 0. Model FP FV FI, prototype FP FV FI. FPM by FPP is equal to FEM by FVP is equal to FIM by FIP. FI by FE of model is equal to FI by FE of P. REM is equal to REP. Geometric similarity is necessary condition for kinematic similarity and kinematic similarity is necessary condition for dynamic similarity. Common dimensionless numbers in fluid mechanics. Reynolds number is equal to inertia force by viscous force is equal to rho v L by mu. Frodin number Fr is equal to root of inertia force by gravity force is equal to V by root GL. Mach number Ma is equal to root of inertia force by elastic force is equal to V by root K by rho is equal to V by C. K is equal to bulk modulus. Weber number W is equal to inertia force by viscous force, inertia force by surface tension force. Surface tension force is equal to rho V square L by sigma. Euler number is equal to root of inertia force by pressure force is equal to V by root delta P by rho. For perfect dynamic similarity, all dimensionless numbers must be same for model and prototype. However, it is difficult to match more than one dimensionless number between model and prototype. Therefore, only number related to dominant flow is matched. Lennon's law of similarity. It is used when viscous force is dominant in the flow. Example: internal flow through closed duct, flow through pipe, flow through AC duct, blood flow in veins. External flow over a completely submerged object, flow over car, flow over a cricket ball, flow over subsonic aeroplane, etc. Dynamic similarity of viscous force REM is equal to REP, VL by VL by V is equal to VL by V of P. Vm by Vp is equal to Vm by Vp plus into Lp by Lm. Vr is equal to Vr by Lr. Discharge ratio theta r is given by QR is equal to VR into discharge QR is equal to VR into LR. QM by QP is equal to AM by AP into VM by VP. QR is equal to AR into VR is equal to LR square into VR. QR is equal to VR into LR. small r into LR. Time ratio is given by TR is equal to TM by TP is equal to LM by VM by LP by VP is equal to LR by VR is equal to LR by VR by LR. TR is equal to LR square by VR. Acceleration ratio is given by VR by TR is equal to VR by LR by LR square by VR. AR is equal to VR square by LR cube. Force ratio is given by FR is equal to MR AR is equal to rho R VR rho R VR into VR square by LR cube is equal to rho R LR cube into VR square by LR cube. FR is equal to rho R into VR square. Froday's law of similarity is used when gravitational force is a dominant force in the flow. Gravity-driven flows, open channel flow, pond, river flow or dam spillways flow through orifice or at bottom of tank. Flows with wave drag, flow or ship, flow or river, flow or column of river bridge. FRM is equal to FRP V by root GL. M is equal to V by root GL P. VM by VP is equal to root of LM by LP. VR is equal to root LR. Q is equal to AR. VR is equal to LR square into root LR is equal to LR whole power 5 by 2. TR is equal to LR by VR is equal to LR by root LR is equal to root LR. dr is equal to VR by TR is equal to root LR by root LR is equal to 1. FR is equal to MR AR is equal to rho R V bar R into volume is equal to rho R LR cube. Okay, these are questions based on the incomplete similarity. If one of dimensionless number related to the flow is ignored, then such similarity is called incomplete similarity. Example for model study of ships, overall drag depends upon both RE and FR. For perfect dynamic similarity, both numbers must be same for model and prototype. For ship model, CD is function of RE, FR is equal to CDF of RE, CDW of FR. For perfect dynamic similarity, REM is equal to REP and FRM is equal to FRP. VR is equal to VR by LR. VR is equal to root LR. VR by LR is equal to root LR. VR is equal to LR power 3 by 2. Above condition shows that same fluid cannot be used for model and prototype. Otherwise, LR is equal to 1. If it becomes difficult to find suitable fluid which satisfies above condition. Therefore, in model studies of ships, Reynolds number is missed, only Frodde number is matched for model and ship. This gives correct wave drag coefficient but not frictional drag coefficient. Frictional drag coefficient can be obtained accurately using boundary layer theory and added to wave drag coefficient to obtain correct value of overall drag coefficient. Done.